Hello everyone, welcome to my channel. In today's video, I shall explain a very important theorem based on properties of circle. Here it is told that O is the center of the circle. AB and AC are two equal chords of the circle. OP is perpendicular on AB and OQ is perpendicular on AC at M and N point respectively. We have to show that PB and QC are of equal length. Here P and B and Q and C are joined by broken lines, dotted lines. How to show this? Let's see. Look. OP is perpendicular on AB. Okay? It is already given. OP is perpendicular on AB. So we can say as it cuts AB at P. So we can say that it cuts AB at M. It cuts AB at M. So this is OP, this is AB. It cuts AB at M. So we can say that M is the midpoint of AB. Let's explain it. OP is perpendicular to AB. It cuts AB at M. It cuts AB at M. So we can say M is the midpoint of AB. Why? Because we know if a perpendicular is drawn on a chord which is not the diameter of the circle, then it bisects the chord. I repeat, as if a perpendicular is drawn from the center of the circle to a chord which is not a diameter, then it bisects the chord. You have to state the reason by the side. Okay? So here we get M is the midpoint of AB. So from this we can write MB equals to half of AB, right? Let's take it as equation number 1. Similarly, we get OQ is perpendicular on AC. OQ is perpendicular on AC. It cuts AC at N, right? At this point. So, by the same logic, N is the midpoint of AC, right? By the same logic, same reason, that if we consider a perpendicular from the center of the circle to one of its chords, then it will obviously bisect the chord. Okay, so here we get that N is the midpoint of AC. So from this we can write NC equals to half of AC. Let's take it as equation number 2. Now since AB equals to AC, therefore half of AB equals to half of AC. Hope it's clear. Therefore, half of AB means what? MB. And half of AC means what? NC. Let's take it relation number 3. Now, look students. OP and OQ in figure are the radii of the circle. So, of course, they are equal in measurement. Here, OP equals to OQ. Radii of the same circle. Okay. And look, OM is the perpendicular distance of the chord AB from the center O, and ON is the perpendicular distance of the chord AC from the center O. And the chords are equal, and we know equal chords are equidistant from the center of a circle. It's a very important property of a circle. That is, if you consider a circle, if you consider two of its equal chords suppose these two chords are equal in measurement, then make sure they are equidistant from the center and vice versa. This is a very important property of theorem of circle, very important property of circle. Okay, so we can use this particular property to show that OM is equals to ON. Right? In this case also OM equals to ON, as they are the perpendicular distances from the center O to the chord AB and AC respectively, where AB and AC are the equal chords. So by that reason we get here OM and ON are the perpendicular distances of AB and AC from the center O. Therefore, OM equals to ON, as equal chords are equidistant from the center of a circle. Therefore, we get, look, so we get OP minus OM equals to OQ minus ON, because two equal quantities are getting subtracted from another two equal quantities. So obviously the remainders are also equal. Therefore we get OP minus OM equals to OQ minus ON. So what does it give? OP minus OM will give us PM, and OQ minus ON will give us QN. Right? So this is another relation. So here we find PM's length equals to QN's length. Let's make it as equation number 4. So now we shall use this 3 and 4 to prove the congruency between these two triangles. One is this one, another one is this one. Means this triangle and this triangle. So let's prove the congruency between these two triangles now. So from triangle PMB, and triangle QNC, we get PM equals to QN from 4. Right? This relation. We get MB, means this one, MB equals to NC from 3. Now it is already given that OP is perpendicular on AB. So obviously this one is 90 degree. Now we get that angle PMB equals to angle QNC equals to 90 degree by given condition. So we can say that the triangle PMB is congruent to triangle QNC. PMB is congruent to QNC. So of course we can write that PB, measurement of PB, equals to measurement of QC, and that was the thing to be proved. So we get PB equals to QC because they are the corresponding parts of the congruent triangles. As here we can write CPCT also. They are the corresponding parts of the congruent triangles. And hence the statement is proved. I hope the explanation is clear to all of you.